Okay, so in this video we're going to look at quadratic models. So this is where we're using a quadratic to model a real life situation. So we're given this situation where an arch is in the shape of a parabola. So just thinking about what a parabola is. So a parabola is a curve. It could be this way round or it could be this way round. Parabolas are always symmetrical about a point. So they'll be, so this side of the graph is symmetrical to that side of the graph. They always have a maximum or minimum point, and they can always be modelled using a quadratic. Okay, so that's the key point here. So we can use a quadratic equation to describe this curve. Now the thing to just be aware of is that if we have a quadratic, there are various forms we can put a quadratic into, and one of those forms is the completed the square form. So if I consider my completed the square form, which looks like that, so if I can get my equation into a form of y equals something multiplied by x plus or minus something all squared plus or minus something, then that is the completed the square form. And if I have it in that form, then the turning point is x coordinate of the negative sign of this, so the opposite sign of that, so the opposite sign of what's in there, so that is going to be minus b, and then the y value is taken from there. So the turning point can be a maximum or a minimum, it depends on which way round the graph is, but the turning point will always be that. Okay, so let's apply that knowledge to what we have here. So I have this equation. It says the arch can be modelled by an equation of the form that. Now, interestingly enough, that is not quite in this form, is it? Because I've got a minus x here. I've got minus, this could be written as minus x plus what? Plus q, couldn't it? It's the same as minus x plus q all squared, but this is a positive x here. So what I'm going to do is I'm going to rewrite this equation, and just watch what I'm doing here, and I'm not changing anything at all. I'm going to write that like that. Okay, and I can do that because it doesn't matter if I multiply a value by -1 if I'm squaring it, because the end result is going to be the same, isn't it? I've just taken the negative value of what was in there. I've just multiplied the whole lot by -1, change the signs. Okay, so they are equivalent, and I've got it into the form that I like now. So that tells me that, can we see that this here is this part here of the completed the square form. So that's the R is the sort of the C bit. So my R is equal to 30. Can we also see that this bit here corresponds to this bit here? So what I need, I've got a minus q there, so my q is going to be 20. Now what I'm just going to do at this point is I'm going to put those two values into that original equation, okay? And this is just a tip, I suppose, just to use your calculator to check problems as you're going along. So I'm going to type in this equation with these values substituted into the original one, okay? So do 30 minus 0.0625 bracket 20 minus x squared, and let's see what it looks like. Okay, so I've got the curve. It might not quite look like that, so you might need to adjust your V window to make it look nice, and I'm going to do G-solve and a max, and I can see that my maximum value is 20 and my maximum point is 20 30, which is what I was looking for. So those values seem correct. Okay, so that's a nice little check you can do. Right, so the next thing we're going to do It's find the horizontal distances from O of the points on the arch which are 10 metres above the ground. So let's think about what we're doing here. So we've got this arch which goes up to 30. So I'm going to, this isn't accurately drawn, but never mind. So what I want to know is what are the x values at the points where this graph, or this y value is 10, yeah, of where the arch is 10 meters high. Okay, so what I'm going to have to do is to solve this equation. So I'm going to put my two values in. So I've got my y equals 30 minus 0.0625 20 minus x all squared. So that's my equation, and I want to solve where that equals 10. So y equals 10, 30 minus 0.0625 20 minus x squared equals 10. It's really important to write that part in an exam, because you would get a mark for that, because that's the you interpreting the question and starting off the maths. Obviously mistakes can now happen, can't they? So I'm going to continue with this to solve. So the first thing I'm going to do is expand out this bracket. So that gives me 20 times 20 is 400 minus, I've got minus 20x, and there's going to be another minus 20x. That's going to give me minus 40x, and plus x squared equals 10. So I'll bring the 10 over here, so that gives me 20 minus, I'm going to expand out this bracket, 0.0625 times 400 is 25. That times 40 is 2.5, so that's going to be plus 2.5x, and I get minus 0.0625 x squared equals 10. So I'm now going to go up here now. So I'm just going to get this into the form that I like, because I'm going to go to my calculator in a second. So I've got minus 0.0625 plus 2.5x minus 5 equals 0. So that is a form that I can use to stick directly into my calculator. So I'm going to go into an equation, I'm going to go polynomial, I'm going to go to 2, and I'm going to type 0.0625 plus 2.5 and minus 5. And I'm going to press the solve button, and I get, I'm just going to write this in surd form as well as decimal form, because it'll just maybe help us to understand it and think that we may have the right answer here. So my smallest value, so that's my x1, is 20 minus 8 root 5, which equals 2.11 meters. x2 is 20 plus 8 root 5, which equals 37.9 meters to 3 significant figures. Now, just looking at these values here, this gives me a lot of comfort, because remember when I said at the start that a parabola is symmetrical about its turning point, that can we see that there's this, the x value of the turning point is 20, and the x1 is 8 root 5 less than that, and the x2 is 8 root 5 greater than that. So there's a symmetry there, isn't there? So that feels quite nice. Yeah, that feels like we've got the right answer. Okay, so let's carry on with the next bit. So what is the horizontal distance between the two ends of the arch? So what we are looking for now is this here, aren't we? So So I guess what I need to do at this point is find the find this value here, so that I can solve y equals that value to find this value here. So that would be the thinking there, wouldn't it? That's the distance that I'm looking for. So I'm going to have to find this y value, and that is where x equals 0. So what I'm going to say is that x equals 0, y equals, and I'm going to go from this equation here, aren't I? So I'm going to go 30 minus 0.0625 times 20 squared. And let's bung that in the calculator, see what we get. 30 minus 0.0625 times 20 squared, and I get 5. Okay, so what I now want to do is to solve this equals 5. Okay, so let's put that. So I've got 5 equals 30 minus 0.0625, 20 minus x squared. Now, what I should end up with here is one of the solutions needs to be 0, doesn't it? Because we know one of them. So that's going to be a nice little check, isn't it? So let's sort of manipulate this. I think I can use the calculations that I've got from up here, can't I? So I've got 5 equals 30, and my expansion of that lot there is minus 25 plus 2.5x minus 0.0625x squared. I've just used my calc, rather than expanding this again, I've just used what I've done up here to help me. Okay, so let's simplify this. So I can see that's going to simplify to 5, and that's going to cancel out with that. So I'm going to end up with minus 0.0625x squared plus 2.5x equals 0. Because all of these integers are going to cancel out. I'll go to my calculator now, I think is the simplest way of doing it. So we'll go there. Polynomial degrees 2, and I've got minus 0.0625 plus 2.5 and 0 in my C. I solve, and I've got one x coordinate as 0, and I've got the other one as 40. So the distance from the bottom of the arch to the top of the arch, this is 40, this is 0, so the distance is 40 minus 0, which equals 40 meters. Okay, so that's my distance between the two parts of the curve, two parts of the arch. Okay, what restrictions must be placed on the value of x for the model to be valid? Okay, so this arch, I presume, is sitting on the ground or on, I don't know, on some platforms or something like that. It only works in this range here. So it's quite straightforward, isn't it, that we cannot take an x that is negative, it wouldn't make sense, and we cannot take an x that is greater than this value here, which we know is 40. So x must be between 0 and 40 inclusive, and that would be how we would write that restriction. Okay, so that, I'm trying to get the whole thing on the screen for you to see it one go, but I should take a photo and put it on the slides, is how we go about those. Okay.